I am going to explain you on data link layer. In fact, as you know, data link layer is the layer next to the physical layer. In the last class, we have learned about various layers of the OSI model, and we are all aware physical layer is responsible for all the physically existing things in a network, and physical layer is responsible, it explains about the electrical, mechanical properties, characteristics, the synchronization, bit level synchronization, all these things. This data is called as raw data, which is the input for data link layer. Now data link layer has certain responsibilities and we are going to study them in detail. Data link layer, in fact, the responsibilities of data link layer are all called as data link control. Mainly, data link layer has three responsibilities, and these three responsibilities put together are called as data link control. They are nothing but data link layer. First, it does packetizing. In the figure you can see it does the packetizing, flow control, addressing and error control. In fact, data link layer takes the raw data from the physical layer, converts them into frames. For each frame, data link layer adds a header at the beginning and a trailer at the ending. The header added by the data link layer contains mainly two important fields. In fact, it contains several fields, out of which two important fields are the source address and destination addresses. The size of the type of the addresses added by the data link layer are called as physical address or hardware address. The size of these physical or hardware address added by the data link layer is 48 bits long. In fact, this we have already studied earlier. So once after doing the packetizing, the data link layer fundamentally takes care of the line discipline. Line discipline, error control and flow control, these three put together are called as data link control. Line discipline, in the sense, it is a data link layer which decides who has to send the data from one machine to another machine. So it is the data link layer which maintains the line discipline within the channel so that there will not be any collisions. And also it is a data link layer which is responsible for error control. As we know, errors are the unexpected changes within the data. For instance, if you send a bit 1, by the time it reaches the receiver, due to any reason, it might become 0 or vice versa. The sender would be sending a bit 0, by the time it reaches the receiver, it might become 1, rather it might be interpreted as 1. These are called as errors. In fact, errors are three types: single bit errors, multiple bit errors and burst errors. Single bit errors are nothing but the errors wherein within a single byte or in a frame, if there occurs a single error anywhere, for instance, if a bit 0 becomes 1 or 1 becomes 0 anywhere, only at one place within a single frame, it is said to be a single bit error. Rather, if such single bit errors appears more than one place within a single frame in a non-consecutive fashion, they are said to be multiple bit errors. Similarly, if the multiple errors comes in a consecutive fashion, one after the other, for example, if 3 or 4 errors comes one after the other in a consecutive fashion within a frame, it is said to be a burst error. As we are all aware, only the single bit errors can be corrected, whereas it is not possible, rather advisable, to make an attempt for correcting the multiple bit errors as well the burst errors. In fact, people, they say burst errors are the worst errors. So even error control is the responsibility of data link layer. Further, the third most important responsibility of data link layer is flow control. In fact, flow control, in the sense, it is the data link layer which controls the overflow. In the sense, every machine, the sender machine, for instance, every machine has some amount of empty space left over for the temporary storage of data within it, to whom we call as buffer. What will happen is, the sender machine, when it sends the data, in some multiple frames, they travel through the channel, they reach the receiver. The receiver machine takes only one frame at a time, check for the errors. Only if there are no errors, it receives. Otherwise, what will happen is, at some point of time, these packets, they fall within the buffer, and the position of the empty space we left over in the buffer of the receiver is not known to the sender, due to which at some point of time the receiver's buffer will be overflowing. This is called as overflow, and this situation has to be controlled, and it is the responsibility of data link layer, or it is the data link layer which will also take care of the overflow control. In a point-to-point configuration wherein only two nodes are connected with a dedicated link, the data link layer uses inquiry acknowledgement as a protocol. In the sense, each time in this, the sender will send only one frame at a time, and inquiry acknowledgement is the protocol used by the data link layer for line discipline, for maintaining the line discipline. Whereas, inquiry acknowledgement is the protocol used by the data link layer to maintain line discipline in a point-to-point configuration. And similarly, in this, overflow control, to control the overflow, data link layer uses stop and wait protocol. In the sense, each time the sender will send only one frame at a time, stops and wait for the acknowledgement from the receiver. The sender will send another frame only after receiving the acknowledgement from the receiver. In this way, each time it sends one frame, receiver receives it, check for the errors. If there are no errors, it receives and it sends acknowledgement. Otherwise, it drops the packet and sends negative acknowledgement. This way, by using inquiry acknowledgement protocol, the overflow can be controlled in a point-to-point configuration, and this is how the data link layer controls the overflow in a point-to-point. Similarly, in a multi-point configuration wherein multiple number of nodes are connected, like in a local area network, to control the overflow, data link layer uses a more sophisticated protocol called sliding window protocol. It is a sliding window protocol through which the sender will come to know the vacancy, the empty space left over in the buffer of the receiver, and accordingly the sender machine will send the packet. Thereby, each time the sender is careful in sending the number of packets so that overflow can be controlled by the data link layer in a multi-point configuration. So, dear students, these are the three responsibilities mainly we discussed. These are primarily the responsibilities of data link layer are the line discipline, error control and overflow control. It is the line discipline which decides about who should send the data now. It is the error control through which data link layer controls the errors, and it is the flow control or overflow control by means of which overflow can be controlled by the data link layer. So all the three responsibilities like line discipline, flow control and error control, these three together are called as data link control, rather the prime responsibilities of data link layer. Thank you very much for your patient listening.